This is part 3 on how faster than light speed observations in astronomy are ignored. I've already done 2 videos on this, and this is picking up from what another video on the internet says. So this is the video I'm going to refer to. It's from the Science Asylum, and it says the cosmic illusion no one talks about. And so the first thing to note is the interesting title. No one talks about it according to that video. Actually, it's a problem in cosmology stroke relativity that physicists usually like to gloss over, ignore, and not make the general public too aware of. Another thing to note is the word illusion. So it's trying to make out that observations of faster than light for galaxies is an illusion. So the video starts off as follows.
We all know that things are smaller when they're farther away, right? The size of familiar objects gives us a way to tell distance. Except it doesn't.
So the claim that it does not always work is bizarre, but as we will see, it's based on beliefs about light speed, c being constant, and that's in vacuum free of the influence of fields such as the field of gravity, and with a lot of contortions tries to fit into the belief about c, and ultimately a change in the meaning about that belief about c occurs. So this is a reminder of the video part 2, where I went by information from this paper. And it's the problem with time in the Lorentz transformation. I'm just going to assume you are familiar with these equations. You have the Lorentz transformation, that's the first equation there, and the Galilean transformation for time is the one below that. So starting from the Lorentz transformation for time, you take v as a low speed, and what is the gamma factor approximately then equals 1, and then that equation for the Lorentz transformation for time approximately equals that equation t minus vx divided by c squared. And the trick being used was to think that v tends to 0 when vx divided by c squared tends to 0, but that's not what happens, because as v tends to 0 can make the x term arbitrarily large. So that means there's no reduction of Lorentz transformations to Galilean transformations. So probably be better saying that as make v small can make x big to compensate. So smaller make v, then bigger can make s. Thus the term vx divided by c squared never tends to 0. That means for the Lorentz transformation for time, that tends to t prime as equal to t minus vx divided by c squared, and it never tends to the Galilean transformation of t prime as equal to t. Thus there's no reduction of Lorentz transformations to Galilean transformations. Lorentz transformations is the maths of special relativity, and usually interpreted as imposing a speed limit c. I would argue against that, but putting that issue aside. But now it doesn't impose speed limit c on the Galilean transformations. Thus Newtonian physics does doesn't have speed limit c imposed on it, meaning that the claim that events transformation produced Galilean transformations at low speeds as being a good approximation is a false claim. But based on the false correspondence principle, the mainstream then restricts Newtonian physics to be less than the light speed c and doesn't allow Newtonian physics to have speeds greater than c. Thus we have two versions of Newtonian physics. You've got the version where Newtonian physics is forcibly restricted by the speed c, and the other one, the correct version of Newtonian physics, where it's not restricted by the speed c. And mainstream have based their belief on the first one, where they're going to be speeds restricted by light speed c, and they're going to ignore astronomical observations of speed greater than c, and that's abbreviated as FTL, faster than light. So what we're talking about here really is in the context of treating space as not expanding, and that's meaning treating it as approximately, not expanding as a good approximation. The expansion of space was dealt with in my previous video, misconceptions of Big Bang. So the video from Science Asylum is going to build upon believing that Newtonian physics is restricted by speed c, and that's false belief. And I'll come back to anon.
Doesn't always work. I mean, you're still good if the distance is less than like 9.5 billion light years. But there are plenty of galaxies more distant than that, and they look bigger than the closer ones.
So what the person says is really straight on to the faster than light problem and not considering option 2. And option 2 is the correct Newtonian physics, which is not restricted by light speed c.
This demonstration is an example of angular diameter. It's the idea that if something is farther away, it'll look smaller in our field of view. Imagine there's a sphere around your head. There are 360 degrees all the way around in any direction, regardless of the sphere's size. If you see a ball at some distance, it'll take up a fraction of those 360 degrees, meaning you can measure its diameter as an angle, hence angular diameter. If the ball is closer, the angle will be larger. If the ball is farther away, the angle will be smaller. That's why one of these clones looks farther away than the other. His angular diameter is smaller. Of course, our brains aren't precisely measuring these angles and doing calculations. Instinctively, you only need a vague idea of distance. So your brain cheats by using visual cues from the environment, like perspective. If I replace this background with one that has less depth, your brain gets confused. It looks like I have a mini-clone. We call this forced perspective. They took advantage of this trick in Lord of the Rings to make the hobbits look smaller. We run into a similar problem in astronomy.
So this is a picture of what the angular diameter issue is all about, where you can estimate the size of an object, which is a distance away from you.
Environmental cues don't exist in outer space. We only have the vast emptiness between objects. So it turns out that angular diameter is not a great judge of distance in astronomy.
So there are no environmental cues or clues in outer space to help you work out what the size of galaxies are in the past. Were they bigger or smaller in the past? Are they growing bigger or shrinking or staying the same size? So issues like that we are not really going to consider here.
But when we measure distance in other ways, the pattern still holds up. Kind of.
When he says kind of, really that means have to bodge things a bit.
Say we've cataloged a bunch of identical galaxies at various distances. From what we just learned about angular diameter, we'd expect the pattern to look like this. An object's apparent size should be proportional to 1 over its distance.
So that's what it should look like based on the theorizing so far presented from this person. But actually, what we get is going to be shown as the following.
What we actually see is this. They match up at first, but quickly begin to deviate. The strangest part of the pattern occurs here, at about 9.6 gigalight years. That's where the angular diameter takes a U-turn. Galaxies start appearing larger again. What? I know. It sounds unbelievable, but it's true. We call it angular diameter turnaround.
So what that means is I'm going to have to move the goalposts, do an add-on to the theory. The theory is not working, so have to make some changes to it. And another thing to note is he's not going to deal with the issue of can alternative theories be used for this turnaround. Instead, he's just dealing with interpretation from one theory, and that one theory is going to be from the point of view of the relativity perspective, and that relativity perspective is based on beliefs about relativity, and those beliefs, as I've dealt with the other videos, are really misunderstanding of relativity. But first he's going to give a bad metaphor, and what he's going to say next in this clip, it's not really relevant to anything, it's just mush.
And I'll admit, it's weird AF. I've heard it described as watching galaxies sink into a pool of diluted blood. And given the redshift, that makes complete sense. Are they actually being diluted, though? Well, no, I just thought it would be a nice metaphor. Anyways.
So, getting back on track after that, the way relativity is dealt with is that it moves goalposts. It has extra things added to it, or initial claims amended in some way, and I've dealt with that in many of my other videos. So for dealing with this problem of the relativity theory not working, I have to do an add-on.
Angular diameter turnaround is just an optical illusion, and like any optical illusion, it comes down to the behavior of light.
He says it comes down to the behavior of light, so have to consider the behavior of light, and of course it's a subject that people can argue about.
The first thing we need to know is that light has a finite speed. It's about 300,000 kilometers per second, or 186,000 miles per second, give or take.
So what we are onto now is assumptions, and the main assumption being about light speed c from special relativity, and are dealing with assumptions that are thought to agree with what special relativity wants. This is from his perspective, and interpretation of observations being based on assumptions. With this, light speed c, need to know what that speed is relative to, but people who believe in special relativity usually never go into details about c relative to what. Anyway, putting that issue aside and proceeding.
That might seem instantaneous on human scales. It's even pretty fast when you consider the entire Earth. But one step out in scale and we start to see the problem. Another step, and it looks as if it's standing still. Light takes time to get places, and space is big. Really big. Units can be misleading. Kilometers and miles are terrible units in outer space. It would be more helpful to say that light travels at 1 light year per year. Alpha Centauri is the closest star system to the Sun, and it's a little over 4 light years away. That means light takes over 4 years to travel that distance. 4 years! And that's the closest one.
So all of that is messed up by them misunderstanding special relativity, and you need to see my other videos on that. Anyway, as for angular diameter,
we can certainly draw the angular diameter triangle on this image, and Alpha Centauri is close enough that the simple rule applies. But in general, it's becoming clear that time is going to be a major factor. Let's incorporate that factor now before things get too heavy. If you haven't guessed it already, I'm going to use a space-time diagram.
So now on to the issue of the space-time diagram. In special relativity, it's flat space-time. That's the way it's usually presented. While in general relativity, you're allowed curved space-time. And next he's going to be talking about the time being on the vertical axis. Why the vertical axis was chosen just seems to be a tradition.
Why is time on the vertical axis? I mean, we had to pick a direction. Why not vertical? I mean, as Michael Stevens would say.
It's a choice. It's a choice.
That choice was made a long time ago. It's just tradition now. Tradition!
Right, so moving on.
Anyway, the Alpha Centauri system won't move much in 4 years, at least relative to Earth. So in a space-time diagram, they'll be on parallel paths. Your first instinct might be to think starlight moves like this. But remember, light travels at a finite speed, 1 light year per year. So we don't get to see this star as it is now. We only get to see it as it was, 4 years ago. There's a delay. Light has to travel along diagonal paths in a space-time diagram. We call them null paths. For mathy reasons I'm not prepared to get into today. Just go with it. The long sides of that triangle defining angular diameter are null paths. For some perspective, that same triangle looks like this in a space-time diagram. I know, I snuck an extra dimension in there on you, but I promise there's a payoff at the end of all this. Light from either side of Alpha Centauri A travels along 45-degree diagonals to reach Earth. But if we consider all the 45-degree diagonals, we get something special. A light cone. Specifically, Earth's past light cone. Every event that could possibly have affected the present-day Earth is inside it. All light that could possibly have arrived at Earth travels along its edge. But this video is not about nearby stars. It's about distant galaxies. Which means we need to extend this light cone much further into the past. In fact, we'll be extending this cone so far into the past that it won't even look like a cone anymore. At least not like anything a rational person would call a cone.
So what we're on now is the light cone, and as he says, not what a rational person would call a cone. So messing up the usual meaning of cone. The relativity point of view messes up a lot of things with its changes it's making.
Anyway, this brings us to the second thing we need to know. Space is getting bigger as time passes. It's expanding.
Right, when it says space is expanding, that's an extra assumption being added, and it's from how they want to interpret general relativity. that get this extra assumption. Space itself is expanding. Thus have motion of space with objects being taken with this space motion, where Newton, without the restrictions, it would just be motion of the object in space and no space expansion.
That means light isn't the only thing moving here. In the time it takes that light to arrive at Earth from a distant galaxy, that galaxy and ours will have moved farther apart.
So light effectively travelled a greater distance than we'd expect from the speed c. So speed is greater than c from perspective of the correct Newtonian paradigm. And that is the Newtonian paradigm that allows speeds greater than c. The mistaken Newtonian paradigm they want speed restricted to be less than c for material objects. So from that falsehood, they want space expansion to give speed greater than c.
We're not seeing that distant galaxy. We're seeing an image of that galaxy from when space was smaller. In other words, an image of that galaxy from when it was closer. For a nearby star, the space-time paths look like this, parallel. For distant galaxies, it looks more like this. The paths diverge. In an expanding universe, the distances between most galaxies get larger over time. But we don't see them as they are now. We see them as they used to be. Light from those galaxies has to travel along the edges of our past light cone. That's those null paths I was talking about. The farther the galaxy, the further into the past we see. So the reason they look closer is because they were closer? Yep.
As from the correct Newtonian paradigm, with speed greater than c allowed, light went faster.
But it's more interesting than that. If we could extend the past light cone indefinitely like this, we wouldn't actually get the pattern we see. Our angular diameter graph would look like this instead. It would deviate from the simple 1/distance rule, but galaxies would still continue to get smaller. There wouldn't be an angular diameter turnaround like in our real universe. Something else is going on here.
So from the relativity point of view, way of looking at it, when it says something else, what that means is so need another add-on to the relativity point of view.
Which brings us to the third and final thing we need to know. Light is also affected by the expansion of space. Yes, really. And I'm not just talking about redshift, though that does happen. Light is dragged along, just like the galaxies are. Light just happens to be so fast that it's better at overcoming that expansion than galaxies. Our past light cone isn't actually a cone. The null paths gradually curve toward the Big Bang singularity.
And that's curved space-time, and that makes in the correct Newtonian paradigm that have variable light speed. So not just restricted to c for light speed in empty space vacuum. Light can go at different speeds.
Would you call this shape a cone? I wouldn't. But then again, I'm not sure what else to call it either. It's giving me serious Taj Mahal vibes, though. Anyway, the turnaround point is right here. Light coming from beyond that hump spent some time moving away from us at first. The distance was increasing faster than the light could move. What?
Greater distance, so light travels greater distance than the c would allow. Gives that in terms of relativity point of view when could do by the correct Newtonian paradigm.
This is the detail that makes angular diameter turnaround possible. Even before the turnaround point, galaxies begin appearing larger than they should. but they still continue to get smaller the farther they are. It's not until 9.6 gigalight years that we see them start to get larger again. Why this happens is perfectly clear from the space-time diagram. All light currently arriving at Earth is coming from a point along the edge of the shape. If it's coming from a galaxy, then it's coming from when that galaxy crossed those null paths. Beyond the hump, looking at further galaxies means looking at closer images of galaxies. All we ever get to see are images of the distant past, filled with illusions of cosmic proportion.
That's basically the end, and glossed over how distance is measured to these galaxies. So have these add-ons, which is the movement goalposts, to the relativity point of view to give the fit to observations. And this is done instead of a consider possibility, can do with the point of view of the correct Newtonian paradigm, where speeds greater than c are allowed. With the space expands point of view, still have to admit that faster than light is observed, that faster light being faster than c. Then talk is of local light speed c, but from some coordinate frames can have speed greater than c. Local light speed gets us into another bodge used by the relativity point of view to be dealt with in part 4. So the summary is the basic idea: mistake is made by having the Newtonian paradigm restricted by light speed c, giving a false Newtonian paradigm, and then there's a need for speeds greater than c from observations, so I need to get around that by adding extra assumption to the relativity point of view of space expansion being allowed greater than c, i.e. it's all built on the false claim that Lorentz transformations reduced to Galilean transformations at low speed as a good approximation, while the correct Newtonian paradigm has no such restriction, allowing speeds greater than c. You also note that with the title of the video, it was trying to give the impression that faster than light speed as observed by galaxies is an illusion, while a straightforward Newtonian paradigm with the correct idea that there's no restriction on it, then it definitely is speeds greater than c. Thank you, that's the end.